So the question is, how do you exclude signals when a certain condition happens, right? So you build a system and you have a bunch of signals, but when one specific condition on a chart happens, you want to remove those signals when that happens. So that is basically the question there. And so now I have the task of trying to create an example here. So all right, so bear with me while I get things kind of set up here. So I'm just gonna make some example signals here. All right, so I'm just gonna take the inflection solver. We're just gonna see when price reverses direction here and change it to price. Right, so there we go. So pretty straightforward, right? Every time a bar reverses direction, we get a signal. And then I'm just going to add a very simple filter here. So I'm going to use the threshold solver. And I'm just going to look at the MACD. Right? So whenever the MACD is above or below the 0 line. Right? There we go. Let's search, filter out the MACD. There it is. All right, so I'm just going to use the standard settings, and I'm going to use the actual MACD plot. So whenever the MACD plot itself is above or below 0. Yeah, so I don't need to change the threshold rules here. Default settings for the threshold rules is good enough, right? So whenever the MACD is greater than 0, right, or above the 0 line, we're going to get a long output. And whenever the MACD is less than 0, we're going to get a short output, right? So there we go. So we can see the MACD is fluctuating around that 0 line there. And now I'm just going to use an AND node here and filter that out. There we go. So we only get short signals when the MACD is below 0, right? So since this is our filter here, right? Circle when we're short, outline when we're long. And so there we go. So now we can see, right? We only get short signals, right, when the MACD is short, and we only get long signals when the MACD is above 0 or long, right? Pretty straightforward there. So these are just some example signals here that I can work with, right? So now we can get to the question of, how do we filter out signals here based on some other condition. Now I have to find something I can work with as an example. So let's see here. How about, I'll use the stochastics and, let's use a moving average. All right, I think this will work here. So what I'm going to do is, if the stochastic is, let's see here. Yeah, if the stochastic is oversold overbought or oversold, then I'll remove signals whenever that stochastic is above 80, right, or below 20. So whenever the stochastic is oversold or overbought situation, we'll remove those signals there, right? So that means we're going to remove these long signals here. Right. And possibly, it looks like we're going to remove this short signal here. It's hard to tell, but it looks like the stochastic could be below 20 or oversold there. Right? So, So, all right, so let's get BloodHound back open. Right. Now, the way removing a signal, based on some condition here, right, like this simple one of the stochastic being overbought or oversold, is a component of an AND logic node, right? So if you haven't consciously kind of realized it, right, these signals here only work when, right, so we have the this inflection solver, right? And it's generating longs and shorts, all the time, constantly. And then we have this MACD filter, right? So we get these periods of longs only and shorts only. So whenever the long signals match up, we get a long output, right? So let's connect this back in, right? So we only have long signals because both the inflection solver and this threshold solver are producing a long output on the same bar, right? On the same bar, right, at the same time. And so, right, and so since this threshold solver is never producing a short, right, during this period here, and I guess let me draw one more rectangle here so we have a reference here. There we go, right? So since our threshold solver, right, only has a long output, right, we only get these long signals or long outputs, right, from the other solver. So both solvers have to agree to having a long output together or a short output together, right? So that's what the AND logic node does. So when you want to exclude a certain condition, or when you want to exclude signals when a condition happens, then you take a solver, you identify that condition, and then you reverse it so that there's no output here, right? So basically, we're going to identify when the stochastic is overbought and oversold, and then reverse it so that we only get an output when the stochastic is inside, right, in between this area here, right, this area in the middle here. So let's go ahead and get that done. So this is going to use the threshold solver. All right, so this is stochastic overbought, oversold. So let's plug in the stochastic indicator here. I'll do a little quick search for it. Okay, there it is. And again, I'm just using, the standard period settings here for this example. And yeah, what we're seeing on the plot here is the %D line there, so that's already selected for us. We're good to go there. And now we need to go into the threshold rules. And so we want to identify when that stochastic is greater than, what do I have, 80, or if the stochastic is less than 20. So, right, so this is the overbought territory, and this is the oversold territory there. Hit apply. So there we go. So there's our stochastic, overbought and oversold. Right, now, so remember, we want the opposite of this. So we only want signals when the stochastic is in the middle territory here. Right, so we have to do a couple of things here. Right. So, for those of you who are probably take to this pretty well, you might just be thinking, okay, let's just invert that. And that almost works, right? So when we invert that, if we look now, right, when the stochastic is in the middle here, and all right, let's clear out some of these objects here, right? So when the stochastic is in the middle here, notice BloodHound, or I should say, this solver here now gives us a long and a short when it's in the middle here, right? So effectively, that's what we want. That's exactly what we want. However, now when the stochastic is overbought, we actually have a short output, right? So that means that it is possible to get one of these, short signals here, it's possible to get a short signal when the stochastic is overbought, or a long signal when it's oversold. Right? Let's look at our stochastic solver here again. Right? So when the stochastic is oversold, right, we have a long output. Right? But if the goal is to make sure there's no possibility of any signal in any direction, when the stochastic is overbought or oversold, right? We only want to allow signals when stochastics is in the middle. Then we have to remove this long output here, right? We have to remove that short output, sorry, and we have to remove this long output here. So make sure there's no output at all when it's overbought or oversold. So we need to do, so we're going to restructure this a little bit differently. So I'm going to turn the invert off there, and what I'm going to do is we're going to grab a function node here, and we want the long short modifier, connect that in, and the mode that we're going to use, there's actually a couple modes we can use here. We can use maximum, we can use addition as well there. These are all just kind of mathematical formulas here, but I think the easiest ones to remember is probably just maximum or minimum, but in this case we want maximum, right? And so when we change it to maximum, look, we get a long and a short now whenever it's overbought, and we get a long and a short when it's oversold. So this is exactly the opposite of what we want. So now that we have the opposite condition here, now we can invert that. And now we have exactly what we want. So we got rid of the shorts that used to be here, right? And we got rid of the longs that used to be there. So now that there is no output at all, that means when we tie this into our AND node, right, that means the AND node will remove all signals, right, during this period. So there we go. So let's connect that in and connect that up like so. And there we go. Our three long signals disappeared, and our short signal disappeared there, right? So again, all that's needed is, right, you need to set up a solver, and you might also need, a function node here, this long short modifier, and create an output here that has no output based on whatever condition it is that should block or prevent a signal, like so. Right? So, all right, so here's one example here, and I'll make one more here. But first, let's see here. First, I like to rename my long short modifiers here to tell me what mode it's actually in, right? So this is in the maximum mode here. So I'll just type in maximum like so there. All right, so that's one example there. So let's just do one more for good measure, right? Because this is something here that I hear more often, right? So this stochastic example is just kind of a, to teach the concept, to teach the theory. I don't think traders really actually do this. I don't, maybe they do, but at least I don't get asked about that in the workshop that I recall here. But something that's more common is I hear, traders want to remove signals whenever price is near a moving average, right, or touching a moving average. something like that, right? So that's what we want to do here. Actually, let's connect that in. So let's see here. End up removing a bunch of these signals here. There, something like that. So, so we need to identify first. We need to identify when price, right, is touching some moving average, and or when price is near a moving average, right? So yeah, I think, like for example, we don't have any signals, but you can see some of these bars, they're not touching, but they are near, right? Like the wick is near that moving average, right? So we could exclude those signals as well. Let's see if we, yeah, like this one, this guy here. So this bar is not touching, but it is like a few ticks or maybe a point or so away from that moving average. Yeah, so all right, so let's move this out of the way. Down. All right, so to identify if a bar is touching a moving average, that's going to be a comparison solver. Right, so if we analyze it, right, when a bar is touching, the high price is always above your moving average, and the low price is always below the moving average, right? So, like, in these bars, the low price is actually above. Both the high and the low is above, right? Or both the high and the low are below. So those bars are not touching, right? So we can look for that condition when the high is above and the low is below at the same time. So that'll be a comparison solver here. Alright, so we're going to be looking at the high and the low price at the same time and comparing that to our SMA 30. Yeah, I think this is a 30. Yes, okay. Alright, so input A is going to be our high and low price there. There we go. We'll set it to price. And so let's see here. So we'll generate a long output when the high price is above, and we'll generate a short output when the low price is below. And so now input B, that needs to be our moving average here, which is an SMA 30. So let's adjust the period. There we go. And what we're looking for is a long and a short output together, right? So those are the bars that are touching, right? So whenever the high is above and the low is above, right, we only get a long only, and vice versa here. So we need to filter out all the bars that have a long and a short output together at the same time. So that, again, is a job for the long-short modifier here. Okay. This time, we're going to use the minimum mode here. There we go. So we set the mode to minimum. And so now we have all the bars that are touching. So we've identified the condition where we want to prevent signals, right? But again, we need to reverse this because we're preventing signals, not generating signals. So just like we did here, right, we inverted everything. So let's take our long-short modifier. We can invert that, right? So now, whenever we see, right, the racing stripes, right, the brown, green, and red together, whenever we get this brown filled in area here, right, those are all the bars where a signal can occur. So let's connect that up. And let's connect that filter in. And so there we go. So that one was removed. All right, so that bar is just barely touching our moving average. Yeah, we know that bar is touching. We know that bar is touching, so those were removed. Right? So now let's work on the bars where the wicks are within X number of points from that moving average. Let's include that as well. So let's see here. So yeah, so let's take another comparison solver like so. And again, input A is going to be price. And let's see. Yeah, I'll put high and low in here again, just like we did with the other solver. And once again, our input B is our SMA 30. Like so. Now we need to go in and adjust the rules window here, right? So previously we were able to just use the default settings here for the comparison rules. But this time, let's see here. I believe, yeah, I'm on the NQ. So let's say if price is within, I think 5 points is probably reasonable there. All right. So if the high is greater than, let's do greater than or equal to the SMA, and so in this case, we're gonna take a look at this bar specifically. Actually, I like both of these bars here, right? So the high price is underneath it right now, right? So we need to take the SMA. So we're looking for the high. Well, actually, yeah. No, you know what? Yeah, actually, I'm going to use the equals. This will be a little easier. So yeah, typically there's a couple of ways to do something here, but let's use the equal condition here, right? Because now it creates this range. So now we can see, is the high equal to the SMA within a 5-point range, right? So and let's hit apply and see what we get. Well, all right, so that's not exactly what I was looking for. Oh, yep, okay, hold on. Yeah, let's reload the chart again, just like I needed to do with the stochastic solver here. And oh, there you go. Sorry, that got reverted back. All right, and there we go. Let's put the 5 points in there. There we go. Okay, so this is what I was expecting to see. So we're getting a long output here whenever the high price equals the SMA within this 5-point range. So there we go. So we can see, all right, all of these high prices, right, those 3 bars are within 5 points of our SMA. This bar here, that high price is more than 5 points above the SMA. And here, right, we have the low is just, looks like it's just barely within 5 points, right, above that SMA, right? So as we look at all these, so this high is just within, that high just outside that 5-point range, so on and so forth, right? So we have our detection here, but again, notice we're only getting a long output or a short output, right? And when we need to prevent a signal, right, we want, well, yeah, in this case, so if we left it like this, yeah, let me explain this another way. If we left it like this, then this would only prevent a short signal on this bar. And on these 3 bars, it would only prevent a long signal. But if we want to prevent both short signal and long signal, right, whenever we get an output here, if we want to prevent both long and shorts, either way, then we need a long and a short output at the same time here. Right. So we're going to, I'm going to take this guy and let's make a copy and I'll paste it here, right? So this long short modifier is already set to maximum for us and it already is inverted for us. So if I connect this up, then there we go. We already have, right, the inverse already set to go. Here, let me kind of take a step back. Let me take the invert off, right? So there we go. So now where previously, right, this only had a short output, now it has a long and a short. And remember those 3, those were long outputs only, but now we have, both outputs, right? So that is the condition where the bar is near our SMA, but again, we need to invert that to exclude those bars from having a signal. Yeah, so if we want to exclude those signals there, we need to take this and invert it like it was before, right? And then again, I can just connect that into the AND node, and there we go. So let's see here. So those bars, is that connected in? Yeah, that's connected in. All right, let me do another reload here. And well, yeah, let me just double check something here. Okay, well, it looks like I was accidentally editing this comparison solver by accident. All right, so let me go fix this. Yeah, you gotta make sure you have the right, make sure you got the right solver selected. If that's easy mistake to make. There's, if when you're moving solvers around, you might be left with the wrong solver selected there. So just be very mindful, when you're editing your solvers, make sure that you got the right ones selected there, because it's easy to forget that you moved something and you left it selected, even though you wanted to, to edit another solver there. So, yeah. All right, so let me set this back up. And let's see, how did I have this before? Okay, yeah, so so that explains how this solver here got messed up. All right, let's apply. There we go. And all right. Yeah, that's looking good. And let me finish setting this new solver up here. And okay, yeah, that one's set up good. And all right, there we go. Okay, yep. Now I got this first solver here put back the way it should be. There we go. Now those two bars, those two signals there are removed, right? Because those bars are touching there. Yeah, so there we go. Right. So again, a summary is, right, the AND node only generates only has an output, I should say, right? Or you only get a signal out of the AND node when everything that's connected in to it, when they all have either a long output all on the same bar, or, right, or all of these solvers here all have a short output on the same bar. Right? So when you want to remove signals, right, based on some condition, right, you make sure that you create a solver or a set here that has no output when that condition occurs. Right? So that's what we've done here. So as far as the stochastics here, right, we have these guys here that, again, if we take a look, right, there's no output when the stochastic is overbought or oversold. So that means no signals can occur, right, during those on those bars there. Right, so if we just connect that in, and there we go. Our signals disappeared there. Right. So, right, it's pretty simple, pretty straightforward. You just gotta be a little creative, in figuring out, okay, how do I identify, my specific condition? How do I identify that? And then you invert it. So we know these function nodes are inverted because they have a white title bar there. Right. So let me, if I select this solver down here, if I invert it, right, you can see the title bar goes white. So that's how you know that a solver is inverted there. All right, so that should do it. That should conclude this one here.